In this video, we're going to solve trig equations using identities. The difference between just solving trig equations is in these questions we've got multiple trig functions and we need to whittle it down so we have only one trig function which we can then solve. So I've included what you get in the formula booklet in section 3.5 and 3.6. So question 1, solve sine x equals root 3 cos x between the domain for x is between 0 and 360 degrees. So we have both sine and cos. We could use cos squared plus sine squared equals 1 by squaring both sides, but that could get tricky. But instead, I'm going to use the identity that tan theta equals sine theta over cos theta. So if I divide both sides by cos theta, I will get sine x over cos x is equal to root 3 cos x over cos x. Well, cos x over cos x is just 1, so I'm left with sine x over cos x is tan, so I'm left with tan x equals root 3. So if I now solve for x, so x equals tan to the minus 1 root 3. So x is equal to 60 degrees. So that is my acute angle. So let's draw our cast diagram. So CAST. So I want tan to be positive. So it is in quadrant 1 and quadrant 3. So that is 60 degrees and that is 60 degrees. So my two solutions are 60 degrees and 180 plus 60, which is 240. So x is equal to 60 or 240 degrees. Question 2. Solve cos squared x plus sine x equals 1 for the range of x values between 0 and 4 pi. So again, we've got a cos and a sine in the equation, so we know that cos squared x is the same as 1 minus sine squared x, so I can substitute in there. So I got 1 minus sine squared x plus sine x equals 1. Well, the 1's cancel, so what I'm left with is sine x minus sine squared x equals 0. So if I factorize out sine x, so I've got sine x, 1 minus sine x equals 0. Therefore, sine x equals 0, or 1 minus sine x equals 0. So that means sine x equals 1. If I solve those individually, I'm going to get sine to the minus 1, 0 is equal to 0, pi, and 2 pi. If I go around again, I'm also going to get 3 pi and 4 pi. And the second one, so if I sine to the minus 1, 1, well, that's equal to pi over 2. There's only one solution in the first complete rotation, so then in the second rotation I get an extra 2 pi, so it's also 5 pi over 2. So in this range of values for x between 0 and 4 pi, I get 0, pi, 2 pi, 3 pi, 4 pi, pi over 2, and 5 pi over 2.